Okay, I think we can get started now. Hey everyone, hope you are all are having a great day. It's Valentine Day today, so wish everyone a happy Valentine Day. Welcome to the 140th episode of YFTT, Tech Talks by Engineers for Engineers. I am Hemant Bhanawat. I am a Director of Engineering at Yugabyte. Today we have with us Ishan Chhangani. Ishan is a database engineer with Yugabyte. He joined us as an intern, and today he will be discussing a feature called Query Diagnostics that he has been working on since he joined. So over to you, Ishan.
Yeah, hi all. Ishan here. So I'm a database engineer in Yoga by DB, and as Iman said, and I've been majorly working on this feature Query Diagnostics. So today's presentation, we shall be discussing about how one can debug queries using Query Diagnostics. So let's jump right in. So in this presentation, we shall be going over what Query Diagnostics is, what is the diagnostic workflow, that is, how one can use Query Diagnostics, and the use cases in which it is useful. Then the function definition and the bundle contents, that is what one gets as part of the Query Diagnostics, as the part of the bundle that is dumped to the disk in Query Diagnostics. Then we'll have a bird's eye view of the architecture, and I'll take you through a demo. And finally, we'll discuss what are the plans we have with this feature in the future. So let's go ahead. So what is Query Diagnostics? It is a feature that is designed to help database administrators and developers troubleshoot and analyze query performance issues. You can think of it as a database's a black box recorder. Like it captures everything from query performance metrics to execution data, execution explain plans while the queries are running. That is, it captures runtime data for a specific query and for the specified amount of time interval. As it is written, it captures detailed diagnostic data across multiple dimensions in a single step. What are the multiple dimensions? I'll take in the coming slides. And after capturing all of that data, later it dumps all of that data to the file system for easy access and analysis. In short, it gives a real-time insight into the query performance, and thus it helps in identifying and pinpointing bottlenecks and resolving such issues. So what is the workflow? So first of all, an SQL engineer can identify the slow query. So there are several ways to identify the slow query. There is a Postgres extension called pgstat statement, which aggregates SQL queries based on the normalization of the queries. And that is one of the ways in which one can identify a slow query. Another way is Yugabyte's web interface. There also we have a page called slow query page. So from either way, one can identify a slow query and get the query ID for that query. Now, just with that query ID, one can trigger YB query diagnostic function for a specified amount of interval. Then once the function has been triggered, for that much amount of interval, it will bundle diagnostic data from multiple dimensions about this one query for this much interval of time. And then one can check the status of the bundle, whether the bundle has been completed, or whether it has errored out, or it has been cancelled, or it is still in progress. That one can check using this view called YB query diagnostic status view. And all of the data later is dumped to this file location. Let us go ahead. So this is the function, the main function, YB query diagnostic function, which initiates a bundle. It takes in 6 parameters, out of which only query ID is a compulsory parameter. For all of the other parameters, we have default values, which I have written here besides the parameter. So I'll go through the parameters one by one. Diagnostic interval second is the amount of time, the interval for which one wants the query diagnostic to bundle each query. Then explain sample rate is so by the way, diagnostic interval second by default is 5 minutes, that's 300 seconds. And explain sample rate is the number of the percentage of the queries that we want explain plans to be dumped. So by default, it is 1% of the queries. And explain, analyze, and distributed are flags that one can set if he wants to get this data as well as part of the bundle. Then we have bind variables query minimum duration. This basically is similar to log min duration, which is any query that takes more latency than this parameter would have its bind variables dumped in this bundle. Now, what are bind variables? I'll take in the next slide.
So Ishan, there is an auto explain extension that is available to also dump these explain plans, right? And it has also similar parameters. So how does it relate to that auto explain extension?
Yeah, it's a great question. So auto explain, yes, it is a. It also has the ability to dump, explain, analyze plans as well. But auto explain is a separate extension in itself. So that's an overhead. And other than that, auto explain is not query ID specific. It dumps explain plans for any query that is executed. But
I see.
here in this feature, we only dump for this particular query ID. And one more thing, auto explain dumps everything into the logs. So when it is on the person to go through the logs and find out the relevant data, whereas here everything is dumped in a separate place.
So I guess this is targeted debugging.
Yeah,
Makes sense. Okay.
okay. So going ahead, yeah, I was just mentioning that we have these two functions as YB query diagnostic is one of the function. The other function we have is YB cancel query diagnostic function, just in case somebody by mistake initiated a query diagnostics, or in case he is no longer in need of the data, he can cancel the query diagnostic function. And YB query diagnostic status view, as I said, displays the current status of any historical bundle or the currently running bundle, whether they have errored out or cancelled or they have successfully been completed and so on. So here are all of the bundle contents that one gets as part of this feature. Note that all of this is only for the query ID that was specified for while running the function, and only for the time interval duration that was given as part of that function. So first, explain plans. Explain plans are down based on the sample frequency. As I already explained, we have an explain sample rate parameter. So based on that only, explain plans are dumped. And explain plans can be really helpful in optimizing queries, not just optimizing, even identifying the bottlenecks within these queries. Next, we have constants and bind variables.csv. So it's a CSV file. What are constants? Constants are basically the fixed values within the query. Say somebody executes select star from a table where ID is equal to 10. So this 10 is a constant. These are hidden in PG star statements and in other views where the queries are normalized. So this data is hidden. And bind variables are basically the same thing, but for prepared statements where we pass $0, $1, and so on. And while executing the query, we give these parameters. So we get constants and bind variable parameters for any query that passes that latency that we gave for this parameter, as I showed you, bind variable query min duration parameter. I'll explain this the use case of it in the demo. PG stat statements, as I already explained, is a Postgres extension that aggregates SQL query based on normalization of the queries. So again, these PG stat statements have the data only for that much duration and only for the query ID that is being bundled. Active session history, so or said as ASH, is a feature that captures real time or historical data based on database sessions snapshots taken at different time interval. It's a really helpful feature in finding bottlenecks. I would highly encourage the viewers, they can go through YFTT 113 by Abhinav, in which he explains how one can utilize this feature. So this feature is also this data is also dumped as part of this bundle. Finally, we have schema details.txt. So basically, it is a mirror of the data that we get as part of slash t when one executes it on PSQL. And but it is for each table that is mentioned within the query that is being bundled.
So there is
So
a question, Ishan. So the question is curious: is this using pgcron to run at that interval, right? As in, are you using pgcron to launch the query diagnostics job at 300-second interval, or there is some other process that is getting launched?
yeah, that's a great question. I was going to cover it here, but the short answer is no. We have a separate background worker which keeps track of the time. Does that answer?
Yeah, I guess so.
Yeah.
Yeah, and one question that I had in the previous slide. Can you go back to the previous slide? Is this information that you have shown here, is this available from other sources?
Yeah, that's a great question. So yes, some of this information is available from other sources, like we talked about already. Explain plans. Explain plans are available as part of Auto Explain, but this feature makes the information more digestible. Apart from that, not all of the information is available. For example, PG start statements here we get only for that much interval of data, and constants and bind variables information simply not available as part of any of the other tools. And one more thing to note here is all of this information not just is not in the logs and is in separate place, but also is very query ID specific. So all of this, for example, for binary dumping any particular query, we have log min duration, but that's not query ID specific. Whereas everything here is query ID specific. Same goes for active session history data as well as schema details as well. Yeah, so I would go ahead.
Yeah, sounds good. Thank you.
Yeah, going over the architecture. So for this, we have done instrumentation of the query layer side code. Basically, all of the gathering of the data happens during the execution phase of the query itself, and then it is stored in shared memory. And from there, it is dumped by a separate background worker, which keeps track of the time as well. And it dumps all of it to the disk for later review. Further, query diagnostics is a very important point that the query diagnostics can be run for multiple query IDs simultaneously, and not just for one query ID at a time. One more point, query diagnostics is available per node and is not aggregated across the cluster as of now.
And I guess since we are able to launch a bunch of different query IDs together, I guess the performance impact of this instrumentation shouldn't be much, right?
Yes, we have done that perf tests on our part, and is not much. Yes, thank you for that question. So I would jump into the demo. So say on some day the SQL engineer comes and he wants to check how the select queries are performing. So he may check PG start statements and get the select query, get the execution time data about the select query. And he observes that the select queries are taking a lot of time, like 649 milliseconds is a good amount of time he feels. And he wants to figure out the reason for it. So he can use query diagnostics to diagnose that. This is the function that he needs to trigger. He can get the query ID from here, and all of the other parameters are diagnostic interval second. That means he is triggering this function for 10 seconds, and the bundle for 10 seconds, and he wants to sample all of the queries, get it, all of the queries explain plans along with their analyzed and distributed data as well. And he wants all of the bind variables irrespective of the latency that they take. So this dumps a path to which all of the data would be dumped after 10 seconds. Uh, we have this helpful view to see that, okay, the diagnostics have been completed. It's been already 10 seconds. And this can also be helpful in realizing which bundle are we talking about. So let us hover over to this path and see. So we see that all of the five files as promised are here, and let us go through them one by one, starting from pg start statements. Here we see that 11 calls were made in this 10 seconds, and yeah, the timings are on a higher end. So okay, but we have explain plans as well. So going over the explain plans, so these are explain plans for all of the 11 queries that were bundled in these 10 seconds, because we had made the sample rate as 100%. And one can immediately see that we are doing a sequential scan. So probably we don't have an index on this column. So a reasonable approach ahead of this that person can take is to create an index. We can also verify this using the schema details data. Yeah, there is a primary key, but there is no index on column. So you can go ahead and create an index on this column. By the time, let us also go through the active session history data by the time the index has been created. So it is a very comprehensive data. I would encourage everybody to go through the docs once. One thing to note here is that you can see that all of the rest of the data is only for this query ID, but active session history data is for that much duration of time, but for any query ID. Because it may be possible that the wait events caused were because of some different event, because of which some failure happened. So now that we have
Hey, Ishan,
the
if you
yeah,
want, you can have some water. You can click. Looks
oh,
like your cup. Yeah.
thanks. Yeah.
Yes.
So I've done a reset to see the latest data. So we'll check the query again, and yeah, it improves the timings, and the person will be happy. So this is one of the
Yeah.
use
So
cases.
if I just can summarize it, right? What we did was we started with a slow query. We ran the query diagnostics. We figured out that yeah, explain plan was had a problem primarily because it was doing sequential scan, and when we added an index to it, it improved, right? So it was a very targeted way of figuring out what is wrong with the query. Okay.
Yes. Now I would also want to show another use case, specifically relating constants and bind variables data.
Hmm.
So let me show you the update query, the same data for the update query. And immediately, as soon as one sees the data, he can see that there's something wrong. It's like it's having such a great standard deviation. Some of the queries are taking 2 milliseconds, some of them are taking a second, 1 second. So to find out why that might be, one can again trigger query diagnostics and see what one. Yeah, so this is the path. Let us first ensure it has. So it is currently in progress. I have put all of the rest of the parameters same just to avoid confusion. Yeah. So now that it has finished, let us hover over. Yeah. So I specifically want to show constants and binary variables data. Let me first explain what this is. The last values of the CSV in each row represents the time that that particular execution of the query took. And here, this are the parameters that were passed, the constants, as I said earlier, were passed to the query, the normalization constant. So, analyzing this, one can see that most of the queries, they are just taking expected times, but you see this 1117 is taking humongous time, and also some others. So one can surely see that these constants have some issue. Now, it might be a hot row problem, that this row is hot and that's why it's taking a lot of time, or it might be a hot shard problem. Let's say some particular shard is hot and all of the data within it is taking a lot of time. So yeah, just wanted to represent that how constants and binary variables can also be helpful in those cases. Would go ahead. So these are the next steps. Currently, the
So
feature.
in the demo, Ishan, in the last
Yes.
demo that you showed, right? So we were able to figure out the problem was with particular bind variables, right, and not with all of them, right? So that way
Yeah.
we can reach to the actual hot shard using this methodology, right? So I think, yeah, makes sense. Okay, okay,
Yeah.
understood.
Yeah. Thank you. So currently, the feature is released as TP technical preview in the release 2.25, and our plan is to make it EA in 2025.1. And in future iterations, we also want a tighter integration with Aeon, that is the web services. Uh, that shall reduce a lot of management with this feature. And I would also encourage all of the viewers that they can go through the documentation and the source code implementation of this feature. And yeah, that's all from my side. Thank you.
Okay, thank you, Ishan. Thank you for your time. Let's wait for any question for some time. Meanwhile, we wait. I have a couple of questions that I would like to ask. Uh,
Yeah, sure.
the first one is about what kind of integration we might be looking at with, let's say, Aeon, right? Aeon, in terms of uh, what is it that could come as part of that integration? And the second question would be like, yeah, maybe let's go ahead with that question. We have another question, but yeah, let's first ask.
Yeah. So there are several areas that we are looking into. First of all, is the triggering of the function, and like I showed, there's a cancellation way and starting and stopping of the function. So all that can happen easier using the web interface, and also the cleanup of all of the data. Further, the display of the data itself using, say, better matrix or graphs can be done using a web interface. I hope that
Yeah.
answers.
Yeah. There is a question from Jim, which is related to the question that I asked. The question is the diagnostic data written to a local drive or to the YB node? Like, where would the data be written if I were running the diagnostics function remotely from a tool like DB or DB Visualizer? Developers wouldn't typically have access to a directory on a YB node.
Yeah, so as I showed, it is in PG data directory. So PG data directory is part of the Postgres is uh, directory where all of the data is dumped. So
Yeah,
within
so
the
so
local
it is
drive,
the YB server node where we are putting in the data, right?
yeah,
Yeah. So probably the question is like developers would want to download this data and they may not have direct access to DB Weaver, sorry, the local node. So I think Jim, maybe Ishan answered it earlier that probably this feature will come with Eon integration, right? So once we have that integration, users will be able to download this data both from YBA and YBM.
I hope that answers Jim's question.
Yeah. Absolutely. Okay. And like from a if the question is about the local drive data itself, then let me have one more question on that. Uh, So right now the data will be written to the local drive and it will be user's responsibility to clean it up, right? Is that correct?
Yes, yes. So currently, because we are in the database section, we are not
Mm.
cleaning up the data. So we dump the data and we display it as part of Query Diagnostics status view. It will be there, and then it is the responsibility of the user to clean up that data. And that is one of the things that I said as part of Aeon would reduce these management jobs of cleaning up the data.
Okay. Okay. And right now the feature is enabled by default or in 2.25, or is there like some configuration that needs to be done to enable?
Yes, yes, great question. So if one goes to the documentation, he'll find the relevant flags that one needs to set because it's a preview feature. So one needs to set certain flags while the start of the server itself, which enables the feature.
Okay.
There are some configuration flags as well that one can tune in.
Okay. And one final question. When we run it for multiple query IDs, right? Can it be the case that a user can run it the same for same query ID multiple times? If no,
Yeah.
what is the error that we will see, or if yes, then how does it work?
Yeah, so currently for a particular query ID, we can only have one query diagnostic bundle running at a time. But we can have, for a particular query ID, we can trigger multiple bundles, but one after another. And for multiple query IDs, we can have simultaneously running bundles. So if somebody triggers another bundle for the same query ID, he will be shown error message on the console itself that this is not supported.
Okay. Okay. Thank you. So yeah, I think I'm done with the questions. Let's wait for 1 to 2 more minutes to see if there are other questions. Otherwise, we can break.
Yeah, thanks.
Okay, I guess there are no further questions, Ishan. So yeah, thank you, Ishan, for your time. It was a good presentation and a nice demo. Thanks a lot, and thank you everyone else for attending this session. Hope you learned something new, and hope you will be able to use this feature. So yeah, thank you. Have a great day. Bye bye.
Yeah.